sample space. Let's see what is sample space here. A set yes, which consists of all possible outcomes of a random experiment is called a sample space. तो किसे बोलते हैं sample space? A set yes usually sample space capital S से denote करते हैं, and which what it consists? The set consists all possible outcomes of a random experiment. अभी हमने random experiment देखा, वो पूरे जितने भी random experiment के outcomes रहेंगे वो पूरे एक set में लिखे तो क्या होगा, वो हमारा sample space होगा, right? So each outcome is called, and each outcome is called sample point, right? So एक outcome है, for example with tossing a coin, उसमें क्या है, एक बार coin is tossing once बोल के बोले हमने, तो two possibilities है वहाँ पे, एक head और tail है, तो head को क्या बोल सकते हैं हम वहाँ पे sample point बोल के बोल सकते हैं, total head और tail को क्या बोल सकते हैं हम उसको sample space बोल के बोल सकते हैं, right? So S corresponds to universal set. यहाँ पे S क्या है? Here S corresponds to what? यूनिवर्सल है, ऑलरेडी यूनिवर्सल पढ़े आपने. यूनिवर्सल सेट क्या है? इसमें पूरे सेट्स आ जाते हैं. यूनिवर्सल सेट, राइट, which consists all the sets. Thus, the sample space yes in each of the above examples are given by, let's see, first example, it is yes equals to h comma t when a coin is tossed once, right? For second one, sample space s equals to when a die is thrown or rolling a die, we have total 6 possible outcomes. And the third one, when a coin is tossed twice, I will write here, coin tossed once, rolling a die, and here H H H T T H T T. So what we have? Coin is tossed twice, right? So it is nothing but sample space. So now events. Next heading is events here. Let's see what is an event in a probability. An event E, it is denoted by E, right? Event is usually denoted by capital E. An event E is a subset of the sample space yes. An event E is a subset of sample space yes if the outcome of an experiment, if the outcome of an experiment is an element of E, we say that, what we say that here, we say that the the event E is occurred. The event E has occurred, right? So an event consisting of a single point of yes is called a simple or elementary event, right? Elementary event, otherwise it is called compound event. Otherwise it is called compound event. So event is nothing but here an event E is subset of a sample space yes. See, it is important. An event is subset of the sample space yes. E is a subset of yes, right? So you can write subsets. Usually here events are what? Subsets of yes, where if the outcomes of an experiment is an element of E, we say that event E has occurred. So simply the outcome of an experiment is an element, single element. So then we can say that the event E has occurred. So again, an event consisting of a single point of S is called simple or elementary event. Otherwise, it is called compound event. So let's say in a random experiment, an element of a sample space must occur, and hence it is called a sure or certain event and an empty set. It is called impossible event since an element of a sample space cannot occur. So let's see an example based on this. For example, in tossing a coin, what we get a sample space here? When a coin is tossed once, we have two possible outcomes, that is h comma t, that is head or tail. So if we designate E equals to h, E equals to h, that is the coin falling head upper. The coin falling head upper, then E is what? It is a simple event as it contains single point. एक ही एलिमेंट है उसके अंदर, सो उसे क्या बोल सकते हैं हम? इवेंट बोल सकते हैं, राइट? सो एंड अगेन इट इज अ सबसेट ऑफ यस, राइट? So it is what we call as a simple event as it contains single point h which belongs to what? The sample space. Yes, similarly it is f equals to t is a simple event, right? So event, what we have, E equals to h, it's a simple event. Similarly event f we are taking, it is also event, it is also simple event. Single element is there, single point is there. So next one more example, we'll take second one. In throwing a die, sample space yes equals to what we get? 1 2 3 4 5 6. So if we designate E equals to 1, that is the die falling with its one dot uppermost, right? So then E is what? E is event, whereas F equals to 135 and G equals to 2, 4 we are taking. Are what? Are compound events. More than one element if it consists in an event, so we can say it is a compound event. Otherwise only a single element is there, then we can say it is simple event, right? So let's see here what we have. 1, 2, 1, 3, 5 and 2, 4 are the compound events as they contain more than one single point, right? So here 2 points we have, here 3 points we have. So for that reason what we call it as compound events. So only single element is there, so we can say it is simple event, right? So next, algebra of events. Next heading is algebra of events. So we have seen that an event A itself is a set, and therefore events can be expressed in the form of algebra of sets. And conversely, let's see, by using the set of operation also, an event in the sample spaces we can obtain other event in S. So let's see first one. A union B is the event either A or B or both. That is A union B, which is equals to omega. Omega belongs to A or omega belongs to B, which is nothing but event A or B. Event A or B algebra, that is union section. We are using sets here. By using a set of operations on event in the sample space S, we have obtained other events in S. So A and B are the events in the sample spaces. Then we are writing here A union B is the event either A or B or both. That is A union B equals to omega, that is belongs to A, or omega belongs to B. We can write it as event A or event B. Next, second one, A intersection B. A intersection B is the event both A and B. That is A intersection B, which is equals to W such that W belongs to A and W belongs to B, which is equals to event A and B. Let's see, observe here, and we are taking here or is the right A and B, so which is equals to event AB. Event AB we can write A and B, AB. Intersection, what it indicates, it's and indicates, right? So these are the events here. We can write it as in the form of set. So next, third one, A is the event A dash, sorry, A dash is what? A dash is the event not A, right? That is A dash, which is equals to omega such that omega belongs to S and omega does not belongs to A which is equals to yes difference A. Already you have studied in the set chapter. Similarly here also we are using operations of set. A dash is nothing but not A. So here the event not A is called, here the event not A is called complement of A, and also denoted by A bar. Next, fourth one, A difference B is the event that is A but not B. That is nothing but A difference B, which is equals to omega such that omega belongs to A, omega does not belongs to B. So here what we have, omega such that omega belongs to B dash, or we can write A intersection B dash. So A difference B means the element belongs to A but not B. So omega belongs to A but omega does not belongs to B dash. Omega does not belongs to B but omega belongs to B dash. So for that reason we can write A intersection B dash. The element belongs to A and the element belongs to B dash. Therefore there is a common element between A intersection B dash is nothing but A only. So these are the algebra of events, right?